This is an electronic load. An electronic load is a device that helps testing, for example, power supplies or batteries, or I don't know, to test like if it is a load that you put in one of your designs to test how it behaves. Okay, so today we are going to show you a tutorial about this device. This device is called the MDP-L1060. That is one device from Miniware that belongs to a set of devices included in a group called the MDP, the Mini Digital Power System. And this mini digital power system starts with this display control module. That is something that is sold apart from this thing. Also comes with this digital power system, okay? And the last one is this electronic load. And they are thinking on having more of them, okay? So you could attach all of them together or apart. That's up to you. Okay. These devices are really interesting, but for these two I already prepared a tutorial, so you could check that. So we are going to focus on this one. The first part I will talk about this one, and the second part of the video I will show some additional functions with a combination of these two devices. Okay. But anyway, you do not need this one to have the basic functionalities of this electronic load. But it's quite handy to have that. Okay, so this device is a very small electronic load that have interesting things. For example, well, it is powered by a USB-C, but it has inside a battery. Okay, so you could use this battery. Is 650 milliampere hour battery, and you have these two connectors that are the connectors for the load input. Okay, the load input port. It has another port here. This is extremely interesting because usually if you have a quite high load here, the thing is that you have a drop of voltage in the cables. Okay, so one interesting thing is to connect this other port that is a remote compensation input port. Okay, it uses an X30 male connector that comes with it, but you need to prepare the cables and so on. It would be good to have these cables already, but okay, if you really need them, you just need to solder these cables here using twisted pair cables, shielded if it is possible, and with a couple of connectors at the other side. Okay, so more things. We have a wheel here for the configuration and all that stuff. To switch it on, as I mentioned, it has batteries, so I do not need to connect the plug here, but I will use with batteries. So I could show you how it works. You could have a load connected here and use it with up to 10 amperes load. Okay, you could configure it for up to 10 amperes load. The maximum load input voltage is 60 volts and the maximum load input power 100 watts. The first thing I will show you are the safety protection parameters. Safety protection parameters are very important. The reason is because if you do not use it properly, you could damage the device that you are going to measure. Okay, in order to configure that, you have to push this menu button during a while. Okay, and appear this one: over current protection, over voltage protection. Okay, do you see that? Over power protection, under voltage protection. So you could configure that let me go to the first one. So for example, over current protection, if you want to modify that, you go here, pushing set, and then with the wheel, you see the wheel? You move the wheel and you could put the over current protection. Although it could go up to 10 amperes and 10 amps, you could say, okay, I'm going to use a device that if everything fails, I don't want this device to work more than 2 amperes or something like that, or 5 amperes. By default, it's 5 amperes. But if you want to disable that, you just put the maximum value, okay? And then again, set. And you could go to the next one, over voltage protection, and you could go up to 60 volts, but yeah, it is configured by to the half, 30 volts. The same in over power protection, 50 watts, and under voltage protection is 0.3 volts. This is especially important if you are going to use like lithium battery and or any other battery to measure. You do not want to have a deep discharge of the battery, so take care with that kind of things. The next thing is to use the different options that you have with this brick. The option is that you could use it as a constant current device, a constant voltage device, a constant resistance device, or a constant power device. How do you do that? Okay, you do that with the set. Now it's not okay. You see it is moving from one part to another, okay? So if you go here, is CC, you see CC here in small, is constant current. And you fix here whatever current you want, okay? And then whenever you push run, it will start sucking that, current, ensuring that you get that current through the cable, okay? And this is constant voltage, the same, you could change that. If you want to go faster, because it goes step by step, you could push set, and while you are pushing set, you move the wheel, okay? You see? And it goes much faster. So more you have here the resistance. It is like if you simulate the resistor, obviously it's a fixed resistor, and you get the current or voltage that is needed. And this is the watts. It's very small, really, this figure, but yeah, okay, you could manage to see that, okay? It's 5 watt at this moment, 5.050. And it is off. It means that whenever I make run, it will start working. There is nothing connected here, okay? But in fact, there is a warning here that is nothing connected. Yeah. So I just stop it, and the fans will stop after a while, okay? So let me see other things that I could do. First thing is to plug something here, and it comes with these cables, okay? So I just plug the black one in the blue one, so it is the load negative, okay? And the same for this other one, you see? Now I will use a battery like this one, a common battery, okay? And I will connect this battery here. So I switch it on again, and let's say, okay, I want almost half an ampere and run, and it is taking that half an ampere, and the voltage goes down to 6.3. This is a 6 volts battery. Really, it's charged up to 7 something. So this is the voltage that you get from the battery. If you increase, because you could change it while it is working, okay, you could increase that, or you just push set and you could go faster. The voltage goes down, you see. It's what I mentioned before. Okay, let's say that now you want to work not with constant current, but with constant voltage. You say, okay, I want it to go down to 5 volts, say something like that, and then you go to 5 volts, and whenever you have these 5 volts, you just say run, and it, okay, over current protection. It means that the current went up to 7 amperes and the current protection was 5, okay? So it is good. We protected the battery of an excessive current, so no problem. Let's say instead of 5 volts, let's say 6, just that, okay? So 6 volts, and we will see what is the current that we get run. Okay, 4 amperes, 3 amperes, and we get almost 6 volts, you see here. Okay, good. And the power, 15 watts, okay. So it is working quite well. Stop. Okay, the same with what I mentioned, okay, like resistor, okay. You start with the resistor and it will use 3 amperes, okay, we'll drop 6 volts. So one of the interesting things here is that you could also program this device. And how do you do that? You need to connect it through the USB to the computer, and you need to introduce a file finished with the extension CSV. And this file, as you see, have different parameters. You say here the number of cycles. The number of cycles means how many times do you want to repeat this program. Also the working mode, if you want it to work as a constant current or a constant voltage. You could see at the top of this sheet. And then having configured these two things, you could go down to the figures and define the constant current, the constant voltage, depending on how you define the working mode, okay? So here in this example, you say like, put constant current 100 milliamperes during 1000 milliseconds. So it's 1 second. Then 0 means it is off. The device will not charge anything. And that during another second. Then 300 milliamperes during another second. Then you switch off during 1 second. And so on, 500 milliamperes and so on, all the cycle. And then you repeat that, as we mentioned, 10 times. This might be useful for some testing of power supplies or other different things, okay? So this is what you could get with this brick. It is quite nice and with its own battery, as I mentioned, so you could use that on the field if you need that with no external connections, okay? So let's see another functions that you could get from this brick. But for these additional functions, we need this screen. That is the display that is used for these modules, okay? And this display is called the MDP-L1060 from Miniware. Has a connection, a USB connection here to get the power. So it would be good to have that like connected here, but it is not possible. So you need to connect that with another cable. One thing I forgot mentioning is that whenever you have that file, a program file, and you connect it, and it is like a USB disk, you just upload the file, and then you go to the menu, so you push the menu during a while, and you remember this over current over voltage, you continue, and you go to program load, okay, set, and then you get here the names of the files that are in this USB drive that has inside, and you just click there and it loads the file. Okay, I do not have one, but it's that way. Okay, so we have this other thing here, and how do you connect this one to this one? Okay, it is connected through a wireless connection from the manufacturer, and I will show you how to configure that because it's extremely easy. You just plug that and you get this thing. I have already this one configured for the power unit, but as it is switched off, nothing comes here. So how do you connect these two devices? Well, the first thing is that you have several buttons here, and you say, okay, I want to select this second device because this one is selected. You see this line, this white line. So here there is no white line, and this is darker than these colors. Okay, and you have this, the P905, that is this device. Okay, P905. So now we have to go to configure, and here you see the address of and the frequency communication of this device, the P905, and we need another one here. So auto match is what we need to do. To move through these menus, we have this wheel, okay? So just auto match, okay? And here I say confirm, C, okay? Confirm. And it will start looking for devices. Confirm. And it is looking for a device, but I do not have the device because it switch it off. So I switch it on, okay? And I go to the menu, go to the here and set, and now it found immediately here, you see, the address. Okay, that's all. Just cancel, and it is already configured. It's so simple. Okay, so I have now these two devices, the P900 that is not connected, and this other one. So I could let's connect this one so you see what happens if you just have this one, to see how it works. That's all. So I use the connector here, I connect it and switch it on. So now it is, I will not use that so far, but it is here detected. You see, now we have this one, okay, and this other one. Now we have selected this one, you see, and I want this other because this one is the power supply and this other is the electronic load. So I click on device, and now it is this one selected. So first thing I want to see is information, info, okay, info. And it shows like more details of the both devices. I have this one selected, you see, the color is different and there is no white line at the top. Now I go to more, you see, I push C, and then I get this menu here with several tabs, okay, battery, dynamic test, factory test, overcurrent protection test, and internal resistor. And we will see how it works. We have this other battery connected here that I showed you. So we will test that thing. The first one I will show you is something very interesting. Is the top one, this internal resistor. How do you move from one tab to another? Pushing the B button, tab, okay, and you just go to these other things. So I go to this internal resistor. This internal resistor is just a test to tell you the resistance of the battery, okay? So I just say confirm, and it will test. It will measure the voltage without any charge and then the voltage with charge, and it will compare and get, that's all, 0.12 ohms. Okay, this is the internal resistance of this battery. What is that? Well, depends on the battery. If you go to another battery that is in not good one, like this other battery is an old battery, you do not see it very well, but it's an old battery and it doesn't work so well. So I will connect it to this other battery. Okay, and you will see how it behaves. Now I have this other older battery and I say confirm to test again. Okay, and now we get this resistance that is quite high, 1.29, so almost 1.3 ohms. This is a lot. The thing is that this shows you immediately that this battery is not in good shape. Let's say that. Okay, so it's a good way to test batteries. Other thing that you could do with batteries is to test the how much charge it could keep. Okay, so to do that, go to battery, this one. Okay, and the only thing that you need to do is to configure these things. This thing says set current is the current that you are going to set, because it will work in constant current for the discharge of the battery. And the end test voltage is the minimum voltage that tells you that the battery is discharged. So you configure that just pushing modify, and to move through these figures you use this wheel. Okay, you could put wherever you say okay, I want to discharge at let's say with this other you change the figure, I don't know, half an ampere or 1 ampere or whatever, depending on the kind of battery that you have. Let's say 800, almost 800. And then I will say backwards go down, forwards go up. And let's say that the test will finish when the voltage is 5 volts, something like that. If you push here, if you change that one to on, okay, instead of off, what it will do is whenever it reaches 5 volts, it will reduce the set current or the current to half of what you fix it. Okay, and it supposedly will increase again the voltage of the battery, and it will continue diminishing it. Okay, so we have that configure, and now we go back, so the previous menu, and now I will push confirm. Okay, and it will start. Okay, you see here it starts with this amount, so it's 800 milliamperes, more than 800 milliamperes, and this is the voltage that we are getting from the battery, and it continue, and the capacity is measured here. So it is starting, measuring the time, and giving you the capacity of the battery. It will continue increasing until the battery reaches the 5 volts. Okay, it depends on the battery. You want to measure, I don't know, depending on the battery, it could have like 5 volts is low or very low or not, or it depends on the battery really a lot. This one is a lead acid battery, but if you are going to use lithium batteries, the voltage obviously will change. So don't take this as it's a real application. It depends on your battery, and you need to see the documentation of the battery. Okay, so it will continue increasing until it drops, and we see that it will take a while because it's still dropping very slow. Okay. Whenever it finish, I will not wait, but whenever it finish, it will say, okay, battery exhausted or something like that. I don't remember. And the figure here will show you what is the capacity of the battery. So far, I will cancel that, but is that interesting? Let's say that we want to do any other test here. Okay. What is this one? This is a dynamic test. What this dynamic test is for? Well, this dynamic test really is something very useful. And in this test, you allow the device to repeatedly switch between two load currents. Okay, you have one current here configured as 1 ampere, but you could change that, and another one at 300 milliamperes. Okay, this can be used to test the dynamic characteristics of let's say a power supply. In the case of a battery, it's not so special, but in the case of a power supply, yes. But as I have the battery connected, you will see how it works. So how you'd modify that? In the same way, modify, and you could change this current. You could then go backwards and forward to this other current, to the time when it is on, time when it is off. So let's say, imagine that I want it to have 1 second on and 1 second off in each of these steps. Okay, so whenever you have that configured, you just go back and confirm starts the test. Okay, and as you see here, it changes. Okay, there is also another test here. This is the factory test. Okay, so I push tab and I get this factory test. What it does is when you configure this, for example, let's say, first of all, you need to configure, I'm going to drop, I don't know, 800 milliamperes, for example, or I don't know, 500 milliamperes from your device. This is not for batteries, especially for your device. And you want to ensure that your device start a test, an automatic test, okay, automated test, and it will check, this device will check if the voltage goes higher, the voltage that you get from your device, higher or lower from these figures, okay, in terms of current and in terms of voltage. Okay, modify, and I go to here and say, like, the top voltage will be 7 volts, low voltage 2, current high, current low, let's say something like 15 milliamperes. So when you have that configured, the thing is that you have to start, okay, with electronic load. You have configured that it will work in constant current, and it will take almost half ampere, and then say run log. Okay, so it starts working as normal, and then this thing is other thing. Okay, this is a test, so it will observe what is happening. When we say confirm, it will start and say here the time, and it will ensure that your limits are between these two. So it's a test that you just leave there, and during a while you could even have a program here running or whatever, and see if your device goes upper or lower than the figures mentioned here. If this happens, like if, for example, I stop the test, okay, here, then it says error output close. This is the kind of error that you could get. Or if you start with it off, less than current low, so it means that you are not getting any current from there, because this is 15 milliamperes and test ended. and the time when it ended. So it's something interesting to test your power supply you design. And let's go to the last one. This is the overcurrent protection. So you say the same, start current, step current, and step time. What does it mean? You say, I'm going to test the overcurrent protection of the device, of the power supply. Let me connect it to a power supply first. Okay, so I have connected a power supply. I use this brick, but you could use any other power supply. Just use this one because I have it. And I configure it to give 6.24 volts and a maximum limit of 2 amperes. Why I put that? Because we are going to do an overcurrent protection test. We will start with 1 ampere, and we will increase by 200 milliamperes every 3 seconds. You could modify that here, okay? Any of the things is with the rest we saw. And whenever we push confirm here, the C, okay, it will start working here and will ask for, will work on constant current 1 ampere. And every 3 seconds it will increase to 200 milliamperes. We will see that. Okay, first of all, we start this working because it's in off. So it is now working, giving 6 volts, about 6 volts, a bit more. And now it's not asked for any current. There is no current at this moment. So I press confirm, wait, prepare, and start the time. And it starts 1 ampere, 1 ampere 2, 1 ampere 4 is increasing, 200 milliamperes, 1 ampere 6, 1 ampere 8, and goes to 2 amperes and stops. And here it says OCP overcurrent protection completed. End current 2 amperes. Test ended after 15 seconds. And okay, this is to test for you when it reaches the overcurrent protection of a device, if you want to test that. This is the last one, and I think for all that is good to have first the brick. I would say with the brick is enough for most of the tests that you are going to do, but it is always nice to have this one, I have to say that, because you have that things and you could have some additional graphs and things like that. So I hope you enjoyed this demonstration, okay? And it's more than a demonstration, it's a tutorial. So you see that this is a very, very easy to use device. It is a bit more complex when you use the display, but it depends on what you want to do. The good thing of the display is that you could add different modules, and you could start configuring all of these devices. And as the company promised, they are going to produce other very nice devices. I'm looking for testing them and doing tutorials for you. Okay, thank you for your time. Bye.
If you like this video, don't forget to like it and subscribe at the bottom of the video. Click the bell to receive notifications when new videos are published.